Unit 2 of the Magento 2 Fundamentals course contains 5 modules. In this section of the course, we discuss important aspects of the request flow process, including the initialization phase, the routing phase, aspects of controller processing, and rendering and flushing output. Request flow refers to the sequence of steps an application takes to process and respond to requests sent to it. The goal of this section is to give you a high-level understanding of the steps Magento uses to receive and process these HTTP requests and then generate HTML responses back to the browser. The diagram shows a high-level application map and a general client-server exchange. The web server sends a request to the application, which is deployed into each front. The application connects to the database and then sends back a response. This all works through a series of calls. For every request Magento receives, the application will take certain steps. Some of these steps are performed with every request, while others are unique to certain types of requests. In the left column of the diagram, all the steps displayed are always performed. A request is sent to the index.php, which initiates the bootstrap. The bootstrap then initiates the app class, in our case, Magento Framework App HTTP, into which Magento loads configuration. Next, the routing process is launched, which goes through every route in the loop until it finds one to handle the current request. How the routing progresses and the loops involved are covered later in this section. After the routing process is complete, there are 2 steps that are unique to every page: controller processing and rendering. In controller processing, the main goal is to find the class that will process the URL. Once defined, the class will demand specific code for this page. Then, the rendering of the containers and blocks, which are all unique to this specific page, occurs. Rendering generates HTML that is returned to the browser, flushing output. In general terms, this is how a request moves through the different routing stages until a response is sent. While the diagram makes the process look simple, it is actually quite complex, so we will cover each of these steps in detail.
Let's take a look at the initial phase of a request flow. So first of all, when a request comes through the server to the Magento application, it goes to index.php. In our case, it will go to pub index.php. This is how our Nginx server is set up. And this is usual and standard configuration. Usually production and very often on development, a request will go to index.php. Another alternative is index.php in the root folder, but it will do the same work as this one. So let's look here what's going on here. So first of all, it will include app.bootstrap.php file. App.bootstrap.php file has some general settings for environmental variables, PHP settings, and so on. It does not perform really any serious work or so. Next, index.php will create an instance of Magento Framework app bootstrap file. Here we have this bootstrap file. So in the constructor, bootstrap, when index.php calls create, bootstrap will start and create object manager factory, which will be used later. After that, Magento will call create application and put Magento Framework app HTTP application. HTTP application implements Magento Framework app interface. There are multiple application objects available in Magento. One is HTTP. Another example could be console. When HTTP application is created, index.php will call bootstrap run, and this line of code will actually start executing request flow in Magento. Let's take a look into the function bootstrap run. Here we go. So basically it will perform multiple checks and then call application run launch, and after that it will perform call response send response. Let's take a look into application launch method. In application launch method, Magento will set area code to the general area object which is available through the whole application, and Magento will configure object manager which has been created before with di.xml file with app.atc.di.xml and with other di.xml file from different modules. After that, Magento will create front controller instance using object manager and call front controller dispatch. After that, front controller class will find a router, it's a routing process, and will execute those router. Router will process an action and return back a result object. Result object then will go back from the launch method back to Bootstrap, and Bootstrap will send it back to the browser. So this is initial phase of the request flow and the final phase of the request flow, which is sent in response to the browser. Later in this section, we will speak about everything that is in between. So we will talk about what front controller is doing, what is the routing process, what are the routers in Magento, how do they process action, how do they generate result object, what type of result objects do we have, how it all works together in Magento.
The initiation phase describes how Magento sets up key objects to work: the Bootstrap object, the app object, dependency injection, object manager, log configs, and more. These are all set up in the initiation phase. Routers are classes responsible for recognizing different types of URLs. Routing converts a request URL into a style Magento can handle, and then finds the class that will be able to process it. The routing process has a set of goals: defining all available routers, converting URLs to Magento-style URLs, parsing request parameters, and identifying an action class that will process the URL.
Every action is encapsulated in a controller class. That is why these classes are sometimes referred to as the action classes. The class contains the execute method where you implement your logic. The execute method processes specific pages.
A router is a class responsible for handling certain types of URLs. Each URL has to be processed by a router class, controller, or action class. Handling refers to the process of finding the right class to process a URL. Certain types refers to patterns. A Magento-style URL consists of 3 parts plus parameters. For example, catalog, product, view, ID, 5. The 3 parts refers to catalog, product, view. Parameters refers to ID, 5. So one router will recognize this URL because of this pattern. Other URLs could have other patterns. Those would be processed by different routers, matching controllers to URLs. The concept behind routers in Magento 2 is to make the router class more granular and flexible so that it can be used in a variety of situations. When we say it handles different types of URLs, we are referring to product view URLs, such as product view ID 1, ID 2, ID 5, and so on. They are different URLs, but the same page, so the router class that processes these pages is the same. Routes are defined in the routes.xml file. Magento 1 requires 5 or 6 lines of code to define a route. Now the syntax to declare a route is much easier, although all the concepts are the same. Historically, explanations about the request flow process have focused on controllers. A controller is a part of the MVC concept. The Magento implementation of MVC is non-standard. Here the controller does not manage data, it manages parameters that come from the request and possible exceptions, and it may do things like initiate a main class for product category pages. It then launches the rendering process, which manages the relationship between view and data layers in production, executing tasks such as loading models, collections, and templates. This code example presents a native controller that uses a set of GET parameters, category, ID, options. The first highlight focuses on the execute method, which will process an action that corresponds to this controller. The second highlight displays how the request object can be accessed from within a controller. The request object provides access to GET/POST parameters.
Continuing with the same example, this code displays how the controller communicates with models. The Magento catalog controller product underscore init product method, product, is created and loaded by Object Manager, providing product ID and other information.
Still using the same controller example, this blue highlight displays how a controller communicates with the view layer, an example of how rendering might work. In this case, a page object is created and rendered by Page Factory. There are other ways to do this. The example presents just one way a controller might render in Magento 2. This code also illustrates how a controller function can catch exceptions. Find any controller class with an execute method in the core. Rendering and flushing output refers to the overall process of sending generated HTML text to the browser. Once the rendering phase is complete, the HTML will be sent back to the browser. Recall, this is the high-level routing flow diagram we looked at earlier in the course. We are now going to focus on the rendering and flushing output aspects of the flow. Magento renders templates by including them inside a class, as in Magento 1, and caching output using ob_ functions. So Magento gets all the output in the string inside the response object. Later, that string goes to output. This process impacts performance to varying degrees. In general terms, the following steps are taken during the rendering and flushing output process. The front controller, Magento Framework App Front Controller, dispatches a request and gets a result object. The app, Magento Framework App HTTP, in the launch method copies HTML to the response object. The bootstrap, Magento Framework App Bootstrap, flushes that HTML from the response object to the browser. See the code example of the rendering and flushing output process in your guide. After a controller is executed, it returns a result object. Currently, there are multiple types of result objects that a controller can return. It is recommended to return an instance of Magento Framework Controller Result Interface. We will later see which classes implement this interface. However, for legacy reasons, native Magento can currently return something else, but it is deprecated. Any return type that does not implement Result Interface will be removed from the native code in the future. Result objects are returned back to the front controller, covered later, and then go to the app object, Magento Framework App HTTP, to the launch method. Take a minute to look at this method in your native installation. Magento will generate HTML and append it to the response object. Response objects are then returned back to the Bootstrap class run method before being flushed. The router defines whether it can handle a URL. If so, it defines an action class to process the URL. Magento has its own standard URL system that maps to action classes with a base router. It is possible to create a custom router that is able to handle custom URL schema. See your course Exercises Guide for instructions on how to complete this exercise and its solution. Request routing refers to the process of managing how client HTTP requests are processed within an application. This module will cover the following related topics: front controller, routing mechanisms, URL processing. Front controllers are the first step in handling requests and workflows across all pages.
The slide lists the main responsibilities of the front controller. Magento provides a set of native controllers, and it is unlikely it will be necessary to modify them. Modification is only possible if there are custom URL schema that have to be processed by a new router. Basically, the front controller controls all the other controllers. In Magento 2, it gathers routes, matches controllers, and obtains the HTML generated to the response object. In Magento 2, it simply furnishes routers created by DI and runs controllers. That's all. In Magento 2, URL rewrites are implemented by a router.
This diagram should be familiar by now. It is the same diagram we looked at in the overview module. In that section of the course, we looked at key code snippets corresponding to application initiation. Now we are going to look at key code corresponding to front controllers and routing. This updated version of the routing flow diagram now shows you the methods that correspond to key steps in the actual routing process beyond application initiation. Note the calls like Bootstrap Run and HTTP Launch, as well as front controller dispatch, which is where the front controller starts its processes. The front controller is not displayed on the generalized execution flow slide shown previously because it is actually a small step in the routing phase of the overall process. We will be using this diagram throughout this unit to discuss these steps in more detail, starting with front controller dispatch. The front controller class implements an interface, as shown in the diagram. Note that the interface is in green. The interface has only one method to implement, dispatch. This example shows the front controller interface. See your course Exercises Guide for instructions on how to complete this exercise and its solution. We are now going to focus on routers in the overall execution flow, looking for the list of routers and matching them to requests. Again, referencing the execution flow diagram, we are now at the point of router match, the most useful method when looking for the list of routers. This is how the list of routers is created, using dependency injection as a parameter. See your participant guide for a reference to the file that will display a list of all the available routers.
In the native Magento 2 installation, there are 5 routers as shown on the slide. Each of these will be discussed in more detail in the slides that follow. First, we have the base router, Magento, Framework, App, Router, Base. Next is the default router in Magento 2, Magento, Framework, App, Router, Default Router. Then we have the processing URL rewrite router. This is how URL rewrites work in Magento 2. Magento, URL rewrite, controller, router. Next, the CMS router, which processes CMS pages in Magento 2. Magento, CMS, controller, router. The last router to take over is the robot controller router when there are no other routers that can take the request. Magento, robot, controller, router. The first 3 routers have equivalents in Magento 1.
The router interface is simple in structure. It contains a single method, router match.
Here is a diagram of the order in which the 5 native routers are processed. The front controller starts with the base router to check if it can handle the request or not. If not, it goes to the next router, URL rewrite, then to the CMS, then to the default router. The last router to take over is the robot controller router when there are no other routers that can take the request.
Each request is sent through the series of routers using its match method to check whether it matches that particular router. If there is a match, true, then an action instance is returned. If false, the request passes to the next router in the sequence. The process ends with the default router as the catch-all. You can create a custom router with its own action instance and dispatch method. To create a custom router, you need to add it as a parameter to the class Magento Framework App Router List. An example of that can be seen in CMS, Etsy, Frontend, di.xml. In Magento 2, the true argument returns an instance and takes charge of the false argument.
In this video, we will discuss routers in Magento. Router is a class which is responsible for handling certain URL schema. For example, we have standard URL, which consists of 3 chunks, like catalog product view or customer account create. There could be different URL schemas. Could be URL rewrites, could be different schemas that could be used in Magento. So router is a class which handles URL schema and identifies which action class has to respond to that URL schema. When execution flow or request flow comes to the front controller from the HTTP app class, it goes to the dispatch function. In the dispatch function, front controller will for each all available routers and will call router match, trying to find the router which can handle current request. When a router is found, it returns action instance, and then front controller will call on that action instance. Let's see, it will call method dispatch or execute. And in the standard action class, method dispatch will call execute. So eventually, in the standard flow, execute method of an action instance would be called. But where does those routers come from? Front controller has a constructor in which it has router list class. Router list class has its own constructor in which it has array of routers. Router list. Now different modules may contribute to that array and add their routers to the list. This is how Magento populates this list of routers. There are 5 routers going out of the box in Magento. Let's discuss them. First one is base router. Base router is in the Mage Framework App Router folder. Base router is responsible for standard URL matching. Base router is one that finds the right action class for the standard 3 chunks URL. So whenever you call something like catalog product view or whatever that consists of 3 chunks, base router will respond to that and will try to find the right controller class. So this router is exactly, and method match action is exactly the place where Magento searches for the right action class. You can explore this class and learn more about low-level details of how this works if you find it interesting. Default router is responsible for no-route handling. It has a whole mechanism behind that using so-called no-route handlers, how to process a 404 page. If no other router will match, the default router will match an action and return a 404 page. Next router comes from the CMS module. CMS module provides its own router. It does some specific work that is related to CMS pages. Next router comes from the URL rewrite module. This router processes special URLs. For example, if you go to a standard category page or a standard product page, a page looks like this: man, top man, jackets man.html. It does not look like a standard 3 chunks URL. There is no man front name and no top man subfolder and jackets man.html.php action class. The same when we go to a product page, we would see something like this URL, which ends with HTML. This is what handled by URL rewrite. URL rewrite will check database and see whether there is some standard 3 chunks router corresponds to this one. And if so, URL rewrite router will substitute this URL with a 3 chunks URL, which then would be processed by the base router. And we can see implementation of the URL rewrite router here. And the last router is robot router. It used to handle some standards robot text requests.
See your course Exercises Guide for instructions on how to complete this exercise and its solution. In Magento 2, the same product can have different URLs. There are several reasons why you would assign multiple URLs: search engine optimization, human reading optimization, and so on. This slide shows the base router URL composition. The base router is implemented by the class Magento Framework App Router Base. The structure of the URL as accepted by the router is base URL, front name, controller name, action name, other params. For an example, see the URL in your participant guide. In the first example, the action instance is created in the base router with the code action instance equals this action factory create action class name. In the second example, the action instance is executed in the front controller. This is the action instance that the base router returns. Action instance equals router match request. And this is how the action instance is executed. Result equals action instance dispatch request. Earlier, we looked in detail at the base router. Now we will examine the CMS router to see an example of a non-standard router. A non-standard router takes the URL, parses it, and converts it to a standard URL. The code to focus on is request, set module name CMS, set controller name page, set action name view, set param page_ID page ID. This code demonstrates how a URL that does not match a standard router is parsed by a new router, which then converts it to a standard format. Other than the base router, most other routers are used only to convert a URL in non-standard format to a standard format. See your course exercises guide. Earlier, we looked in detail at the base router. Now we will examine the CMS router to see an example of a non-standard router. A non-standard router takes the URL, parses it, and converts it to a standard URL. The code to focus on is request, set module name CMS, set controller name page, set action name view, set param page_ID page ID. This code demonstrates how a URL that does not match a standard router is parsed by a new router, which then converts it to a standard format. Other than the base router, most other routers are used only to convert a URL in non-standard format to a standard format. See your course exercises guide for instructions on how to complete this exercise and its solution. Controller architecture describes which methods and classes are being executed by the controllers, how they connect together, which classes the controller depends on, and so on. The section on admin and front-end controllers will describe the workings of the front-end and back-end controllers. Recall that a controller is a class specific to a URL or group of URLs, for example, all product pages. In Magento 2, a controller can only process a single action. It may have different parameters, but it will be the same type of page. We have only one class per action. An example of an action class: Magento, Catalog, Controller, Product, View. If you look at the actual Magento 2 code, for example, the category view page, you will see it has a constructor, the required parameters, and an execute method. Every controller has to have an execute method. Every time a user hits a link, the execute method will take over. The execute method actually processes the URL. When someone enters a URL, it winds up in the action class of a controller. Constructor. The action class holds dependencies to be injected using dependency injection. If a class needs to be inserted into the controller, it must be required in the constructor and then injected by DI. Extra methods and variables. In addition to the execute method, there may be other methods and other variables in a class. Controllers may contain additional methods that aid the execute method. They may be broken up into smaller methods for efficiency, as one action class can extend another. An action class usually extends Magento Framework App Action, but it is not always that simple. For example, Magento Framework App Action, Magento Catalog Controller Product View. Magento Framework App Action Action extends Abstract Action, which implements the action interface. Action interface has only two methods, dispatch and getResponse. Note the interface is highlighted in green to distinguish it from the classes. The diagram shows a hierarchy which extends a class one at a time. Action Abstract Action contains methods for obtaining request and response objects in the constructor using DI, getRequest and getResponse. You must call the parent class when creating the action. Otherwise, the request and response objects will not be available. It is very important to extend every action class from action action, not from action abstract action or action interface, because the dispatch method is implemented here. Action action includes different objects like an object manager, a URL flag, and a redirect. The router calls the controller dispatch method, not execute. A controller will return an action instance from its dispatch method. Summary of the flow. 1. Front controller dispatch is called from the app launch. 2. It finds the correct router, which then finds the correct action class. 3. The front controller calls an action class that then calls dispatch. Magento Framework App Action Action is where the dispatch method is implemented. It then calls the execute method. Sometimes specific action classes are used to extend the action class. The reason is that a wrapper or intermediate class may have some logic that is needed for all action classes in the module. For example, the goBack method. In these modules, the controllers do not extend the action class directly. The product view controller extends the Magento catalog controller product class, which then extends the Magento framework action class. Note, the terms action class and controller are interchangeable. This slide shows the most important result objects, which are page for HTML output, JSON for the JSON database, forward, an object that performs an internal redirect to another controller, redirect, physically redirects a customer's browser to another URL. This slide illustrates how page object can be injected into the controller, created and returned from the execute method. This slide illustrates how a JSON result object created in the execute method can be injected into a controller. Usually, a controller returns an object as a result of the call result setData data, which is a result object. The setData method is used to assign the array to return as JSON. This slide provides an example of forward result object usage. Note that it will perform an internal redirect invisible to the customer. This slide provides an example of redirect result object usage. It will send a redirect header back to the browser, which will redirect the browser to another URL. It is important to have both forward and redirect actions, and forward and redirect methods. They are not the same. Why are there both actions and methods for these functions? Because of the way the routing loop is performed. The controller returns an action instance and requires a true argument, while the action sets it to false within the loop. For example, action forward works indirectly with the request as it is redirected to the next router. Method forward forwards directly. It takes the request, sets parameters, and sets a new controller name. The code is inside the action itself. Redirect works with the response. Check your understanding 2.4.a. Which one of the following statements is true? Action classes are used for forward actions, while controllers are used for redirect actions. The terms action classes and controllers can be used interchangeably. A controller is a wrapper for an action class. The central difference between front-end and back-end, or admin, actions is that back-end actions must support protected access, ACL. To access the back-end, you must log in, so these actions must support ACL to be more protected. Every controller has to facilitate this protection. Recall the methods and actions from our controller classes diagram.
In this code example, the CMS page view controller extends Magento backend app action class. We are going to examine how front-end controllers work, what they extend, what methods they contain, and what capabilities they have. First, let's look at how admin controllers work.
This slide shows the backend abstract action class is a constructor with extra objects injected. The class contains the new dispatch method, the underscore is allowed method, and a set of other auxiliary methods. It also owns the implementation of the backend redirect and forward methods. This slide shows the constructor of the Magento backend app abstract action class. Following common Magento 2 practice, the constructor defines key objects that will be used by the controller. However, we can see a slightly different approach with other classes. Usually, there are many classes declared in the constructor, which are then instantiated by Object Manager and injected using DI. Here we can see the context class, which provides access to required classes. These are the auxiliary methods that are useful in the admin controllers.
every admin controller or admin action class has to extend special action class, which is Magento backend app action. Let's take a look into this abstract backend action class and see what difference does it have comparing to the standard action class. As we see here, abstract action class does not have any code in it. All the code is in the Magento backend app abstract action class. So let's take a look into that. Magento backend app abstract class has a set of auxiliary methods like getSession, working with URLs, breadcrumbs. It has methods for forward and so on. On the backend, URL structure is a little different. So forward URL and all that method redirect should have its own logic to process Adminhtml URLs. In addition to that, abstract action class will have its own dispatch method, where certain admin-related logic is located. Magento will check your security key. Magento will check whether user is logged in or not. And also Magento will perform ACL check, which is done in the isAllowed method, _isAllowed. This method has its own implementation in this class, which looks like this. Return this authorization is allowed static admin resource. Now, when we implement an ACL resource, we should specify its resource name in the admin resource variable. Let's take a look. Let's take a look at the module catalog. Into the admin controller, Adminhtml, and let's say product. Let's say product.php. You would see admin resource constant here set to Magento catalog products, which means that all controllers that would extend this class would have admin ACL resource associated with it as Magento catalog products. And this is allowed method, which is checked in the dispatch method of action class, will allow or disallow access to that action. An alternative approach is to implement your own isAllowed method and perform your authorization. But if you use standard Magento ACL, then the standard practice is to use this admin resource constant.
Check your understanding 2.4.b. Which of the following statements are true? When the underscore is allowed method checks the ACL, the default value it returns is false for safety. The backend abstract action class contains the underscore is allowed method. The underscore is allowed method. This module goes into depth on how controllers work. Matching controller processes describes how Magento finds exactly the right controller for a URL. This is an important process for developers to understand, especially for debugging code. Creating controllers explains how to create and register a new controller. Recall that a controller is a class specific to a URL or group of URLs, and that in Magento 2, a controller can only process a single action. An example of an action class: Magento, Catalog, Controller, Product, View. We once again use the execution flow diagram to highlight where we are in the process. We are focused on the point where a customer enters a URL and the router match responds. The calls that the controller executes are inside the dispatch method. Summary of the flow. Front controller dispatch is called from the app launch. It finds the correct router, which then finds the correct action class. The front controller will call an action class that calls the dispatch method. The action class is where the dispatch method is implemented. It then calls the execute method. The base router has a match action method where almost every action is processed, except rewrites. They are processed by a different router. Every URL the base router processes has the following structure: 3 elements, front name, action path, action, and parameters. The phases of the controller matching process: 1. Define the list of assigned modules. 2. For each module, build a potential path to the action class. 3. Check whether the action class exists. If an action class exists, return stop execution. If not, repeat step 2. In order to create a controller, you have to follow these 3 steps. Create a routes.xml file, create the correct action class, and implement an execute method. Test the new controller. Let's take a look at the native example in Magento, Catalog, Etsy, Frontend, routes.xml. The code example demonstrates defining the ID of the router, the front name, and the module name. You define the ID of the router, in this case standard means base, in the same code in which you define a front name and module name. This example tells Magento that the module is registered to process the URL that starts with catalog.
In this video, we will discuss standard Magento URL to an action class or controller class mapping. Standard Magento URL consists of 3 chunks, as we can see on this example. So here we have a URL customer, account, create. How does Magento figure out which action class should respond to this URL? The first thing Magento does is takes the first chunk, which is customer. Then Magento goes and checks all routes.xml files, which are merged into one big route.xml file in the front-end area. And in the customer module, there is a declaration which connects front name customer to module Magento customer. So what Magento will do, once again, it will go to every registered module, look in its etc frontend folder, search for routes.xml file, merge all routes.xml file together. It will get a huge routes.xml. Then it will check whether there is a route registered for front name customer. So the first chunk of the URL is the front name. So if Magento finds a module which declares this front name customer, it will check, it will see and understand what module is responsible for this front name. Next, Magento will go into that module, into the controller folder, and if we are under the front end, the storefront, Magento will look into the controller folder. If we are in the admin area, Magento will look in controller Adminhtml folder. We are on the storefront, on the front end area, so Magento looks into controller folder. And what Magento tries to find in the controller folder? Now we have to look into the second chunk, account. So Magento will go into the controller folder and search for a folder account. Here is a folder account. In the account folder, Magento will search for an action class create. So now, under the account folder, Magento will search for create. Here we go. Here is this create class. So this is how Magento identifies what is an action class, or we also call it controller class, should respond to the given URL. And in that controller, Magento will call its execute method. Magento might have different URLs. Magento might have a more complex URL like catalog, product, view, ID 1. It may have more chunks than 3. In this case, Magento only takes 3 chunks, and everything else is treated as a parameter. So in this case, we deal with catalog, product, view URL with a get parameter ID with value 1. This is how Magento treats URLs. Magento may have non-standard URLs, which will be processed using URL rewrites, which we will discuss later in this course. One other thing is that Magento may not have the sub chunk and may have a URL like that. We can see this URL if we add product to the cart, for example. If we do so and we go to the cart, we will see URL checkout cart without third chunk. In this case, Magento substitutes index. So URL checkout cart is equal to URL checkout cart index. And then Magento applies the same rules as we discussed before.
Recall that a URL consists of 3 chunks: front name, action path, action name. The rule on how a URL will be converted to an action class name is as follows. The front name is connected to the module, the action path is connected to the folder, the action is connected to the PHP class. Let's take a look at an example. Catalog is connected to the module Magento Catalog. Product is connected to the controller Product folder, and View is connected to the View.php class. This results in the class name Magento Catalog Controller Product View. A short reminder that the action class has to extend Magento Framework App Action Action and must implement an execute method. A simple way to test controllers: enter or hit the URL front name, action path, action. To customize a controller, you can either create a preference or a plugin. The key is that the controller is the same class as the model. In Magento 2, controllers are the same as other classes, so they can be customized in the same way as other classes, using preferences or plugins. This is an advantage in Magento 2. See your course Exercises Guide for instructions on how to complete this exercise and its solution. This module focuses solely on URL rewrites. The process of URL rewriting is used to make complicated URL addresses more user-friendly by making them shorter, more descriptive, and easier to remember. Magento allows you to specify the URL key, URL identifier, on every static, content, and product category page. For example, you can choose the keyword you want and add it to a particular page's URL, independent of the Magento page name. An example of a URL rewrite is displayed on the slide. While the URL on the left is more easily read by people, Magento will use the second one. So, in the browser, the customer would enter the first URL, but Magento will work with the second URL. How do rewrites work? The browser sends a request to the server or application, which will require the use of Magento URL Rewrite Controller Router. Next, it will access the database, specifically the URL rewrite table. In other words, a customer sends a request using a browser, which then goes to PHP and then to Magento. Within Magento, the request goes to the URL rewrite router. There are a couple of routers in the matching controller phase, triggered by the URL rewrite router, which will go to the database. It will simply check and substitute one file name path for the other. Here is an example of the URL rewrite table and its data. This is a display of representative data. Note the request path and the target path. They are substituted in the rewrite as explained earlier. See your course Exercises Guide for instructions on how to complete this exercise and its solution.
Congratulations, you have completed Unit 2. Close this window to return to the Learning Management System and proceed.